Hello, and welcome. Welcome back if you're joining us again, and welcome if you're new here. So, what we are doing here, we are coding a chatbot using natural language preprocessing, which is a part of machine learning. And what we have done till now, we have created this amazing code, which we talked about libraries, we talked about what every library does, and we talked about them in very detail. We exported our we made our data frame, we filled our nan values, we have created some data frames to work with. We looked into text normalization part, we talked about text normalization part in very great depth. We talked about word tokenizer, we saw what is word tokenizer, we talked about word tokenizer. We talked about POS tagging, we saw what is POS tagging, we have created some code for POS tagging. We talked about lemmatization, we saw how to do lemmatization, we talked about lemmatization in great detail. Then we created our own text normalization function, we created this text normalization function. We talked about text normalization, we talked about the definition of it, how we do what a text normalization is, what it does. We saw that in action. Then we created a lemmatized text which takes the context, which is this column, and it normalized it, and we use that text lemmatized text, and we talked about count vectorizer. We talked about what count vectorizer does, what is a count vectorizer, what happens when we use count vectorizer, and we talked about what is fit underscore transform, and we talked about what this line does. We talked about bag of words. We created a bag of words, we looked into the bag of words. Then we talked about stop word removal, we saw what is stop word removal, we did some stop word removal. Here we created a function which does that. We removed stop word from this question, then we lemmatized it, we created a bag of word for that question. We saw what is cosine value, how to get a cosine similarity between that. We talked about cosine similarity, we saw that the cosine similarity formula very much looks like a correlation formula. We looked into correlation formula there. Then we created some we went over text.response from previous we go to our text response, and we create this. We create TF-IDF. What is TF-IDF? We talked about TF-IDF. We talked about TF-IDF stands for term frequency inverse document frequency. We saw what TF-IDF does. We talked about TF-IDF in great detail in previous videos. So what we are going to do now, we will now get a unique value, and we will get a score for that unique value, which we have in our data frame. So to do that, let's go ahead and let's say we will take TF-IDF. I'm making a variable here, and I will say PD, which stands for pandas dot data frame. Again, if I'm writing this, you know that I'm gonna take two data frames here. So we will say x, okay, underscore TF-IDF. What is this? This is this TXTF for IDF. We will say column. I'm not taking a two data frame, I'm saying columns is equals to TF-IDF. term frequency inverse document frequency dot get features underscore features names. So we talked about get underscore features underscore names in our previous video. As you can see, we have looked that into where let's see, get. We talked about get feature name, okay, where we used this function get feature name. Now is here, features cv.get feature names. So we looked into this function when we were coding this. So I'm If you want to know about it, you can watch that video. Get feature name, and we will say td underscore tf dot head to look at like first few data from this. So as you can see, we are getting the unique value and score for that unique value. So what are the score of that unique value, what are the unique value, and if you can see, this table looks very much familiar to this table, which is this. And what is this? This is the count vectorizer form of our lemmatized text, and we calculated which word occur how many times in our data frame, and this gives the unique how many times a unique value is present there and what is the score of that unique value. So we get this. Now we go ahead and say question underscore tfidf. What we have talked about this where, let's say, let's do this. Like we have talked about this, we saw while creating a cosine similarity that there was one error which we were getting of cos thing. So now I will try to get that cos value error which we were getting. tfidf, not get that error which we were getting. So tfidf dot transform questions underscore lemma. So what it is saying that go and use tfidf on question.lemma. Where, what is question.lemma? Question.lemma is this question on our normalized text from which stop word is removed. So take that and do some term frequency in one document frequency on it, and get and store that value into array. And what we can do here, we can say, okay, we have counted our scores, we have calculated tfidf, we are missing something, we are missing column like here, we are missing column. So we will say go ahead and okay, where frequency and tfidf question matrix, we want a cosine form of it, to array, and we want the cos value which we were not hearing, and we will calculate the cosine similarity. And as you can see, when we discussed our cosine similarity here, we said 1 minus pairwise distance, and we took two data sets or data frame. So we will say 1 minus pairwise because we need 2 point to calculate the similarities between them. Pairwise underscore distance, and we will say td underscore tfidf. What is df tdidf? It is this df tfidf. It's getting very tongue twisty, so I'm getting very confused in that. So we will say td df. I'm saying td. What is td there? Well, df tfidf, and we will take question. Okay, I keep on saying td. There is nothing td here. Nothing is represented with td. I don't know why I'm saying td every time. So I'm saying tfidf. Okay, I'm saying take df tfidf this, and question tfidf, which is, okay, we will go above, which is, we should get our question tfidf where, okay, we have created or not, we have created our question TF-IDF. So take this and apply matrix cosine on it, and we saw what this will do. This will give us cosine similarity. So now if we say cos, it should give us, okay, pairwise distances again. Okay, something is wrong there. Okay, let's go cos lemma. Okay, so it should not be here. Lemma to array. Okay, let's run it again. There is some one more pairwise distance. Okay, wait. Cos 1 minus pairwise. Okay, distance. MC ES. Okay, DF TF-IDF. It is right. Question TF-IDF. Okay. Matrices. What is matrix or matrices? METRIC. Matrix. Yeah. Cosine. Okay. Oh my god. So cosine. So now we are getting our cos value, which is cosine similarity here. So be very careful with your spellings, because you can bump into these kinds of error. So after we're getting our cosine similarity, let's go ahead and check the highest. We have actually checked the highest index, but let's go ahead and do that thing again. So what we can do, let's see that we have that code here or not. We should have that code. Okay, index value, where is our index value code? Okay, let's do it again. Let's say index, we want our index value of highest argument value, the argument value with the maximum value. We want our index value of that. So we'll say index value is equals to cos dot arg, which is argument max. We will say it will give us the cosine similarity of the argument which is maximum in our cost, and we want its index value. So what I'm saying, that from this, whichever value is highest, give the index value of that value. Let's say it's a 0th index, first index, second index, and so on. So we want the index value of highest argument value. So it's actually 194th value. The 194th value is the highest value in all of this list of array. Okay, so after this, again, if you want to check, we can check the question. Okay, again there's that. We will say df text response. We are taking a text response column dot, we will say locate. We want to locate an index value, index value 1, and as you can see, index value is the cosine of highest argument. So we are saying that give me a highest value of an argument from the column text response. Okay, there is some error, df index value. Okay, what? Okay, the error is actually, it is not underscore response, it is text response. So this, I'm glad to help. What can I do for you? This text response has the highest index value in this. So what I'm saying, that this is when lemmatized, and when it goes to all count vectorizer and everything, the value which we get is the highest in the list of an array which we are getting from here, which is very similar to the value which are present in question TF-IDF and DF-TF-IDF. So this is what we are getting here. And now what we can say is we can make a function to return a response. So let's do this. We say def chat tfidf and we'll take text and we'll say okay, this is our function. We are creating a function which is chat tfidf and we'll say lemma, which is equals to text normalization. And if you know that this text normalization is a function which we created in earlier video, and it will take a text in that which will normalize it will take some text and normalize it. So what this line will do that, then we say tf is equals to tfidf dot, what we want here, we want a transform of lemma, we want a count vectorizer of that lemma, of that document. We will say tfidf transform. So after normalization we want a count of unique terms and in documents. So we say, and we will pass this lemma in that because that has our text, and we want to get that in array. Okay, this will give us a count vectorizer or term frequency in our document frequency of our text, which is 0 1, the list of our array. Okay, now we will say how similar they are. So we are saying going to say cos 1 minus pairwise, be very careful with your spelling, distances. We get error here every time, so I always forget to put a s, so it will be distances. And hopefully I should not get here error this time. So we want dfi term frequency, inverse document frequency, which is tfidf, and matrix or matrix, it's metric, and we want a metric cosine. The error which we were getting, we were not like writing e at the end of it, so we corrected that metric. Then we will say that get the highest index value, so we will say index value. Let's go ahead and say index value, and we click calculate index value on cos. We say cos, we get arg max, which is argument max. We apply it for the highest value. Okay, now we will say return. Okay, index value, we got our index value, and we will say return. We want something, we want a return df from text response. We want a return from a text response column dot location with the highest index value, which is closer to our question. Get the response which is closer to our question. So we'll say location value. So what this function will do, this will take a text. Okay, it will lematize this text. We have talked about lemmatization. Then it will vectorize that text. It will break it into 0 and 1s, and it will count the number of terms present in them and number of documents present in that, and it will store in that array, in an array. Then we are saying find how similar our question is to our answer, which is our cost value there. Then we are saying the highest value which our text have to our question, get that, because hopefully that is our right answer. That get that value and return it to us from text response, and again we are passing the highest value. So we will do that. Now test this. Now we have created our chatbot. This is our chatbot. So in theory, what we have done, we created our chatbot. Now we have to test it whether it is working or not, or it is giving us some blank or weird response. So our chatbot is done. Now it's time to test it. So we will say chat tfidf. Okay, let's go ahead and say how are you, and it should in theory, and should give just think of me as the ace of slave or something weird, because we have to train on the with the machine learning algorithm. But let's go ahead and see. How are you? Okay, let's how are you? Let's run this. So we are getting just think of me as the ace up your sleeve. What we did, we created our function, we looked into all libraries, we looked into what is computitional, feature extraction, lemmatization, POS tagging, stemming, then TF-IDF, computizer, POS tagging, word tokenizer, and we created a chatbot, and it's working fine. So this is for our chatbot. If you like this video, please subscribe, like, and comment. That helps me, and that helps this YouTube channel to grow because of algorithm, and everything. You have to do these kind of thing. So if you want to if you want to tell me to look into something, I will happy to do that. So please tell me that in comment. And if you love this, like it. If you don't dislike it, you can also tell that in comment that you don't like it or you like it. But yeah, for till next video, be happy, spread peace, and take care of yourself. Bye.